Again, welcome to Statistics and Probability course. Again, collecting data in a reasonable ways. These lectures cover the concept of, in statistics, it's all about variability. And this is Unit 1, Part 1 lectures. So in statistical method, always allow us to collect, describe, analyze, and also draw conclusions from data. And this will be the definition for statistics. The techniques of collecting data, describing the data. Here we use descriptive statistics, analyze or inference, which we use the inferential statistics, and draw conclusion from data. Now, if we live in a world where all measurements were identical for every individual, then these tasks will be simple. So, for example, consider a population consisting of all of the students at a college. Now, suppose that every student is enrolled in the same number of courses. Also, they spend exactly the same amount of money on textbooks, and also all of them favors increasing student fees to support expanding library services. Now, for this population, we will say that there is no variability in the number of courses, also the amount spent on books, or student opinion on the fee increase. Now, a person studied students from this population to draw conclusion about any of these three variables will be an easy task. Again, there's no variability in all the variables. Now, it will not matter how many students were studied or how the students were selected. In fact, you could collect information on the number of courses, amount spent on books, and also on the opinion on the fee increase by just stopping, again, the next student who happen to walk by the library, because there's no variability in the population. So the average or the mean value of tuition would be the same amount as individual amount. So this one individual will improve complete and accurate information about the population. And you could draw conclusion with no risk of error. Now, as part of its regular water quality monitoring efforts, an environmental control board select 5 water specimens from a particular well each day. The concentration of contaminants in parts per million, or ppm, is measured for each of the 5 specimens. And then the average of the 5 measurements is calculated. Now, if all these 5 specimens have the same variable or have the same value, then we can say there's no variability. But here we are assuming each specimen have different values. So the graph here shows an example of histogram, and this histogram summarizes the average contamination values for 200 days. Now, suppose that a chemical spill has occurred at a manufacturing plant 1 mile from the well. It is not known whether a spill of this nature will contaminate the groundwater in the area of the spill. And if so, whether a spill this distance from the well will affect the quality of well water. So 1 month after the spill, we collect 5 water specimens are collected from the well, and the average contamination is 15.5 ppm. Consider the variation before the spill shown in the histogram. Again, will you interpret this as evidence that the well water was affected by the spill? So here we can say that what if the calculated average was 17.4 ppm? How about 22.0 ppm? So before the spill, the average contaminant concentration varied from day to day. So it's an average of 15.5 ppm would not have been an unusual value. So seeing an average of 15.5 ppm after the spill isn't necessarily an indication that contamination has increased. So on the other hand, An average as large as 17.4 ppm is less common, and an average as large as 22.0 ppm is not at all typical of the pre-spill values. So in this case, you will probably conclude that the well contamination level has increased. So reaching a conclusion requires an understanding of variability. And that will be, again, the main objective of this course. So few of the questions we have here and also the example here, we didn't have any conclusion yet. And this is where, again, we are going to get more details on the concept. So in this course, first, we're going to start with the descriptive statistics, how to summarize data, organize the data, etc. Then we move on to inferential statistics. This is where we are going to again collect a sample from the population, and we are going to find out if there's a relationship or association, etc., between the variables. So understanding variability allows you to distinguish between usual and unusual values. And again, that's the main objective in this course. The ability to recognize unusual values in the presence of variability is an important aspect of many stat methods and also techniques. And also is what enables you to quantify the chance of being incorrect when a conclusion is based on a variable data. So that will be the conclusion of our lecture number 1, part 1. Again, that's the main goal of statistics, is all about variability in our data set. So again, see you in the next lectures, and thank you.